Okay, this method is about different methods for finding compound probability. So the first example, when spinning the spinners below, what is the probability of first spinning an A, let's fix that, and then a 3? So written as probability of A and then 3. Now you have a couple different options. You can use a tree, you can use the probability table, or you could make a list of the possible outcomes. Now this one seems like it could have quite a few possible outcomes, so I think I'm going to go with the table. And you have, again, a couple different ways that you could set this up. So our first spinner has A, B, C, A, and B. So I'll go through 2 ways of how you could set up the table, and you get to choose which one. I'm going to first go with showing you where you write out all the different options. So there's 5 sections of the spinner. 1, 2, 3, 4, and 5. Perfect. Okay. And then on this one there's 4. 1 through 4. 1, 2, 3, and 4. Okay. So then you want to go ahead and label everything. So we have A, B, C, A, and B. Okay? And then we have 1, and I'll use a different color for this. We have 1, 2, 3, and 4. So then you use the table like you would a multiplication chart. You want to see where they meet. So this one, everything in this row actually, you've spun a 1. In this row, you've spun a 2. In this row, you've spun a 3. And in this row, you've spun a 4. Perfect. All right, so then you can go through and you can start looking at the letter that you would be spinning. So everything down this column, you've spun an A. And everything in this column, you've spun a B. This column, you've spun a C. This column, you've spun an A. And then this column, you've spun a B again. Okay, so we really are just looking for when we've spun an A and a 3. So if we get our highlighter, anytime you see an A and a 3, you highlight. So there's 1, there's 1. All the rest are either A1, 2, or 4. And over here, the same thing. And the rest of the 3s have a B or a C attached to it. So those ones will not count as well. So we would say for the probability, let me get back to my pen. For the probability of getting an A and a 3, we highlighted 2, so there's 2 out of, and then you want to find the total number of possibilities. So we have 5, we have a 5 by 4, so that's 20, so 2 out of 20. But I'm looking and I see that I can simplify that answer. I can divide by 2 and I get 1 out of 10, so that is the probability. You could also set it up in a similar way, but let me just set up that table first. Now we can look and see that there's only 3 different options. We have A, B, and C. And then we still have 4 different options, 1, 2, 3, and 4. So I'm going to just do 3 options along the top for this first spin, and still 4 along the side because we have 4 different numbers. Okay. So then to set this up, we actually need to know the probability for each one. So looking up again at our first spinner, we have 2 A's out of 5 possible. So for A, the probability is 2 out of 5. We can go back up and look. There's 2 B's out of 5. So the probability is 2 out of 5 again. Ooh, that looks kind of crazy. And then we have C, which is 1 out of the 5 sections are labeled with a C. Okay, and then if we go and we look at the second spinner, we have the 1, 2, 3, and 4. They all have the same probability because there's only one of each number. So for this one, for 1, the probability is 1/4. For 2, the probability is also 1/4. 3 and 4 will be the same. All right. So now you can think of this as our generic rectangle. In order to find the probability of getting an A and a 1, we have to multiply those two together. But since I already know that I'm looking for an A and a 3 together, I can go straight down here. And in order to find that probability, I multiply those two fractions together. So I'm looking for the probability of A, which is 2/5, and I'm going to multiply it by the probability of getting a 3, which is 1/4, and I get 2 times 1 is 2, and 4 times 5 is 20. So I'm getting the same probability, 2 over 20, which I already know is equal to 1 over 10. Okay, so that is an example with 2 spinners. Okay, so now I'm going to look, and I have a new question, and it says, you're going to pick a piece of candy from each bag. If you pick the pieces at random, what is the probability that you get a Skittles and a Milky Way in any order? So I could get the Skittles in bag 1 and the Milky Way in bag 2, or the opposite, I could get the Skittles in bag 2 and the Milky Way in bag 1. So this one I also think it'd be best if I set up a probability table. So I'm going to start that way. And for this one, I'm definitely going to use that second method of labeling with the probability, because this one has 5 options and this one has 7, 10, 11 options, and I don't want to have to write out Starburst, Milky Way, Skittles, and M&Ms 11 times. So bag 1 has 3 options, and bag 2 has 4 options. And since I made it more of a long rectangle, I'm going to put bag 2 on the top, and it doesn't actually matter which order you put it in. So bag 2 is going to go along the top, and bag 1 will go along the bottom. Okay, so bag 1 will be represented, will represent Skittles with ST, or I'm sorry, Starburst with ST, Skittles with SK, and Milky Way will be M. So we have Starburst, we have Skittles, and we have Milky Way. And now we would put that probability in, so we have, 6 options. So Starburst is 1 out of 6. Skittles would be 3 out of 6. And Milky Way is 2 out of 6. Those are my probabilities. Okay, and then bag 2. 3, 7, 8, 9, 10, 11. Good, I counted right this time. So we have Starburst, which we said was ST, and that's going to be 3 out of 11. Milky Way is going to be 4 out of 11. Skittles will be 1 out of 11. And M&M's, which will be MM, will be 3 out of 11. Now we want to first find out where those two are going to meet. So we want Starburst and Milky Way, Skittles and Milky Way in any order. So SK and then M for Milky Way. So we're looking for the probability in this box. And then also we can do it the other way around. So S, K, and M down here. So those two boxes are what we need to find the probabilities of. All right. So again, in order to find the probability, we do need to multiply those probabilities together. So we have 3/6 times 4/11. And we get 12 out of 66. And I know I can simplify that, but for right now I'm just going to leave it. So I'm going to find the probability this way. We have 2/6 times 1/11. And we get 2 out of 66. All right, and now since we found the areas, remember again this is our generic rectangle, we're actually going to be adding those two fractions together, and we have 12 over 66 plus 2 over 66, which is good because they already have a common denominator. So 12 plus 2 is 14, and we're going to put that out of 66. Remember, when we're adding fractions, we don't want to change that denominator. So 14 out of 66, trying to find a number that goes into both of those. I know that 2 does, they're both even, so if I divide by 2, I get 7 out of 33. And since 7 doesn't go into 33 evenly, and it is a prime number, that is the most simplified form of that fraction. So the probability would be 7 out of 33. All right, and our last example is the ice cream shop. So this table over here shows the options at an ice cream shop. And if your friend placed your order without knowing what you wanted, what is the chance that you would get chocolate ice cream with caramel sauce and cookie dough as your topping? So we're looking for chocolate, caramel, cookie dough. So you get one of each. Now this option doesn't work well with the table because we don't have 3 sides of the square to use. So we need to make a tree or make a list. Now either one would work, but you need to start thinking about how many that would actually be. Remember, vanilla can be paired with caramel, hot fudge, or strawberry, and then each of those can be paired with sprinkles, cookie dough, or the crunch. And that is a lot of options, so we want to start probably by making a table. Now, if you're really organized, you could definitely do the list, but if you're not, the table is probably going to be your best option. All right, so I always start off, I'm going to give myself a little bit more room. I always start off on one side with a little dot, and I'm actually going to try to make this look nice. So I'm going to put this off in 3 directions so there's some space. Now, our first option, we want to just go left to right, so we have our ice cream flavors. So our options are vanilla, chocolate, and strawberry. And now you go to sauces, and we need to figure out how many of those we have. We have caramel, hot fudge, and strawberry, so that's 3. So each of these is going to need 3 more options coming off of it. So that's the second layer. And we have caramel, hot fudge, and strawberry. Caramel, hot fudge, strawberry with chocolate again. And then with the strawberry ice cream, the options are still the same: caramel, hot fudge, and strawberry. Alright, and then for each of these, we also have the option of the topping. So sprinkles, cookie dough, or crunch. Sprinkles, cookie dough, crunch. Sprinkles, cookie dough, crunch. Sprinkles, cookie dough, crunch. We have to keep going with those. Okay. So as you can see, there are quite a few options here. Alright. We gotta write all those out. Sprinkles, cookie dough, crunch. Sprinkles, cookie dough, crunch. Sprinkles, cookie dough, crunch. This probably should be SP since we already have S for strawberry. Okay. I'm going to take this for time's sake. And I'm going to just kind of add that down there. Not the best option, but for the sake of time, we will do that. Okay. So now we have to go through and count how many total options there are. So we have 3, 6, 9, 12, 15, 18, 21, 24, and 27. So our probability is going to be out of 27. So now we were looking for the chance that we'd get chocolate ice cream. So we're looking just in this section here with caramel and cookie dough. So there's only one option that's going to be chocolate with caramel and cookie dough. So we have to kind of go down this path and then down the middle. So there is a 1 out of 27. 1 out of 27 chance that we will get the chocolate with caramel and cookie dough option that we want. So that's how you make the tree. They might also ask you something like, what's the probability that you would get an option with vanilla? And so you would want to look and see how many options have the vanilla. I'll use a different color highlighter so you can see this one differently. So it'd be, you go to vanilla first. It could be with caramel, hot fudge, or chocolate, so it's any of these. So 3, 6, 9 out of 27. Which you could simplify this because 9 and 27 are both divisible by 9. So that would be a 1/3 probability.